All right, workshop 2, first problem. Again, process of elimination for these kind of things. So, first thing I notice, I see a triple bond. Definitely see a triple bond. So that would eliminate a couple things right off the bat. That eliminates C, because there's no triple bond. That eliminates E, because there's no triple bond.
Mm-hmm.
I also don't see any OH. Right? There's nothing, there's no big peak here. So that eliminates that. And now I'm stuck between, so I know it's a nitrile. So you have a carbonyl or the alkene. If it's aceto bond O, I should have something here. I see nothing there. I don't see the aceto bond O. So it can't be that. So it must be A. So just a strategy, right? Look for an OH. If there's no big OH or NH, that can eliminate lots of things right off the bat. If you see something in the triple bond region, right, that can eliminate things. If you don't see aceto bond O, right, so those kind of basic things, you can at least get a process of elimination going. And feel free to write down what you're thinking over here too. Okay, so like this one, I see an OH. Look at that thing. That's a big, broad OH. So now, no OH. That's an NH2. NH2 looks a lot different, right? Also, this looks like a triple bond to me. So no, right? This has a triple bond and an OH, right? But do I see the aceto bond O anywhere? Do I see anything here? Looks like nothing's there. So it's not this. So again, we're stuck here, and look here. You can even see the sp3ch is right there, the 3300. So you can see that terminal alkyne peak there too. All right. So what made this one hard is that you had to draw out the structures. If you hadn't drawn out the structures, you wouldn't know probably. So that's D. That's B. That's E. That's C. Oh, better do this. And that's A. So once you draw the structures, hopefully it's a lot easier to see. I'll draw the structures out for you. Again, see the triple bond? See the triple bond? So, no triple bond, no triple bond, no triple bond. Triple bond, but it's a terminal triple bond, so it needs to have that SPCH. I see nothing there, so it can't be that. So it'll basically be the nitrile one. All right. Types of hydrogens or hydrogen signals, same idea. So again, you're looking for that symmetry, whether it's there or not. This one, you do have a little bit. These two CH3s are the same. So 1, 2, 3, 4. Don't forget the OH. For this one, you want to have it, but you don't, because 1, 2, 3, 1, 2, 3, 4. So it's not symmetrical. So these are all technically different hydrogens. For this one, right, these are the kind of ones we talked about, so we were asking before. You can split this down the middle here, right? But that still means 1 and 3 are different, though, right? These are two different types of hydrogens if you drew the hydrogens out. Because 1 is closer to the O than 3 is. 2 is the same, and these 2, 4 are the same. This one, again, find that mirror plane, right, where you cut it in half, and it's exactly the same on either side. So 1, 2, 3, 3 types here. And this is the doozy that's a mirror plane this way and a mirror plane this way, so it has like double symmetry. So that's why you only have 2 types here. These 2 hydrogens, all 4 of these hydrogens in the ring are actually the same, and these 2 are the same. Same idea, carbon NMR, again looking for symmetry. So there's no symmetry here, so 1, 2, 3, 4 different ones. Little symmetry here, so 1, 2, these are all the same. You can cut that in half. These two are the same, and these two are the same. Here you can cut it this way. So 1, 2, 3, and 4. Right? Don't forget the carbons that aren't bonded to any hydrogens. They count too. Now this one you can't though. Right? Because if you try to go this way, there's no OH on this carbon. If you go this way, an alcohol is different than an aldehyde. So these are actually going to be all different. Same with this one. You could try to cut it this way, but again, this OH is different than an aldehyde. And if you try to go this way, there is no OH over here. So you got to be careful. There's no symmetry in this one. So they're all the carbons in this case are different. I do ask for the frequencies down here, but again, that's like that's just essentially using that handout we talked about and giving those ranges. I messed up. There's 5. Because I forgot a carbon. I forgot one of the carbons that doesn't have a hydrogen bonded to it. My bad. As I've told you all numerous times to not forget them, I forgot one. So there's actually 5 different ones.